And now we'll talk about libcurl. Libcurl is a C library for transferring files. It supports lots of different protocols and lots of different options. We're not obviously going to go into an extreme amount of detail about this, but we'll get started on the subject because it gives you an idea about how to do asynchronous I/O using curl as we build up to it. So we'll start off with the ECE interface. This is one of those where naming things in computers is hard situations, and the opposite of easy is not hard or difficult or complicated, but is instead multi. Easy and multi, not antonyms. I think you would have gotten the multiple choice answer correct for on elementary school tests, but we'll see. The ECE interface, however, is a synchronous interface that uses callbacks. And callbacks are a form of I/O that we want to talk about today. So we specify specifically the URL that we want to connect to, and then we specify what we want to happen. So we use the curl library, and we're just going to download the rustlang.org webpage and print it to standard out. So we use the curl library. We create an ECE handle using the constructor for a new ECE handle. We specify the URL to be rustlang.org with HTTPS, otherwise it will fail because SSL is a must these days. And then we configure the callback. And the right callback is the function that occurs when we receive data. This is something that's easy to get wrong when working with Rust. It's something that I know some people have struggled with in other courses that have used the C bindings for it. And the read function is data that we are reading and sending to the remote server. The write function is for data that we are receiving from the remote server and want to write locally. You could make an argument either way for whether this point of view makes sense, that the read callback is we're reading our local data and sending it, and the write callback is we're writing received data. You could argue the other one. I don't want to say it so I don't confuse you. But honestly, it's just a matter of perspective, and I don't think one is necessarily any better or worse than the other. With that in mind, we're going to configure the callback, and our write callback takes here a closure. The data is what we have received, of course, and then what we're going to do is just write all the data to standard out and then say OK. And in the OK function, we have to specify how much data we have processed. So our anonymous function here is, well, also known as a lambda, is going to be invoked whenever the library receives data from the network. And because the data that we receive might be quite large, we could potentially get it in different chunks. And so for that reason, at the end of that function in our OK result, we specify how much data we successfully processed. And it may be the case that we had an error, in which case you shouldn't return OK, you should return an error. But if the amount of data that we processed is somehow less than the library is expecting, then that will also be treated as an error. So you do have to be mindful of that and make sure that you are returning the amount of data that you successfully processed, in this case data.length. The other thing to note about, of course, is at the end when we actually want to execute the curl call, we do easy.perform, and perform means start. In this case, perform is blocking because it's an easy handle. We call perform on it, it's blocking. So that means that we wait until we connect to the rustlang.org URL. Once a connection has been established, we start receiving some data, and then for each chunk of data that we receive, the write callback is invoked, and it may be invoked more than once, depending, as I said, on how much data we've actually received. And so, yeah, we do have to specify how much we have processed. If you look at the original bindings, if you have previous experience with libcurl, I do a lot of command line curl stuff myself. You'll see how the Rust bindings are fairly straightforward translation. If you took ECE 252, you should be familiar enough with Rust, both in the synchronous and asynchronous forms, because that was covered in that course. And just, again, noteworthy, perform, starts the request, blocking until it finishes, and finishes includes having processed all of the data that we were expecting to get. Okay, but that's synchronous. The reason we talked about curl is really the asynchronous multi-interface, because, well, network communication is a very good example of what you want in asynchronous I/O, in that, well, the network can take a long time, from the perspective of the computer, of course. So you start a network request, you move on, you create more without waiting for the results of the first one. And especially if you are sending different requests to different recipients, you certainly would benefit from this. If you're sending them all to the same recipient, they might get queued, and the recipient can only respond so fast, so the remote server won't get overloaded. You might end up waiting, but if you're sending it to different servers, then this is great. Send it to everybody. Let them have it. And the main tool for that is the multi-handle, and the type for that is just multi with capital M, and they return multi-error as opposed to just regular error. So unfortunately, there isn't like a super great way to unify the error handling with the question mark symbol, but we do our best under the circumstances. So the multi-handle is a structure that allows us to contain a number of easy handles, and we can use it to manage a group of them, and we'll start them and we'll check on their progress as is necessary. So once we have a multi-handle, we can add the easy objects, however many we want or need, to the multi-handle, and creating an easy handle is the same as it was when it's being used alone. It's just we don't call perform on it. We put it in the multi-handle instead. And then we add the easy or easy2 object to the multi-handle with add or add2, and these functions return an actual easy handle if we need it. Once we have finished putting all the easy handles in, then we call perform on the multi-handle, which here I represent using bombardment, because you are potentially starting a large number of requests all at once. This function returns on success the number of easy handles that are contained in the multi-handle that are still running. If it's down to 0, then we know they're all done. If that number is non-zero, it means some of them are still in progress. And so that tells us some interesting information about how to use the multi-handle. It does mean we're going to call perform more than once, and that doing so doesn't restart or interfere with anything that's already in progress. It just gives us a status update on what's going on. It also means that you can add more handles to the multi-handle and start them without interfering with the ones that are currently running, anything like that. And every time we perform, we get an update. We might have launched some new ones if they've been added since the last perform. We might have finished some, so the number of remaining will be adjusted to account for that. All those things will take into account what is the current state of each of those easy handles, and in the end, we get a number. And if your intention is to wait for all of them to be finished, then you're waiting for that number to be 0. In principle, you may check as often as you like, but the intention is to do other stuff in the meantime. At the beginning, at least, you might put a couple of easy handles in and start them, and then create a couple more easy handles, put them in, start those, and so on, so that you are spending time, efficiently. While you've started some network requests already, you are working on some later ones, and eventually you will have run out of things to do, most likely. In that case, you can use wait, And the wait function in this case blocks the thread until something happens, something defined in the sense of an event. And this function is going to wait for some handles to be finished. The first parameter to wait is an array of extra file descriptors that you can wait on, but we will just make it an empty mutable array if you need. In this course anyway, we won't do anything that advanced. The second parameter is the maximum time to wait, and the return value of wait is the number of interesting events that occurred. Interesting is the word used in the specification, and it doesn't get a formal definition, so its definition is a little bit mysterious. Oops. Just leave that important thing undefined. I'm sure no one will mind. But for a simple use case, you can just ignore most parameters and wait for something to happen there. In the meantime, with the perform, as Gandalf says, things are now in motion that cannot be undone. As the IO operation moves, it's already been started, the perform operations are running, the callbacks occur when the condition is fulfilled. For a read callback, when we've connected to the server, it starts sending the data. For write callback, when we've connected, we start receiving the data. And as the IO operations are moving on, the easy handles are updated with whatever has happened. Hopefully they were successful. Each easy handle has an associated status message as well as a return code. Why both? Well, one is about what's the status of the request. So it could be telling us that it's done, but does done mean it's finished with success or finished with an error? And that's kind of what the second is about. So the callback parameter message has result 4, including some, which means the request is completed. If we don't have a result for it, it means that handle, the easy handle, isn't done, so we can't decide yet, is it finished, was it successful or not. If there are more handles to look at, we should go on to the next one. If it's done, we should look at a result, and obviously errors are reported with error. Otherwise, everything has succeeded. Now, when a handle has finished, you have to remove it from the multi-handle, and so you remove it that you get back when you check in on the status of one, you get back a reference to that easy handle, and you can just remove it using the remove or remove to function, and it's Rust, so there isn't a specific cleanup function that you have to call. It's just when the easy handle goes out of scope, it will be dropped. Perfect. If you let it remain in the multi-handle, then of course it won't go away until the multi-handle is itself dropped, which you may not want if the multi-handle is going to live a long time, because keeping around the easy handles forever is maybe not helpful. But you can rest assured that you don't have to worry so much about the explicit calls to clean up as you would in C, because Rust. So let's consider a longer example. This originally started out as a code example by Clemens Gruber, which is the source of it originally is linked in the notes. And it was written in C, but I have translated it to Rust, mostly. The example puts together all the things we've put in the compact code segment, and the callback prints the data to standard out. So we have an array of URLs. They are just for websites, Microsoft, Yahoo, Wikipedia, /dot. All we really cared about is having some different websites. And we have our usual imports. And we have a little collector function, which is, so we have a collector structure, and the collector structure is really just a vector of unsigned 8-bit integers, and we're going to implement the handler trait for this. And the handler trait implements this write function, which takes as arguments, well, itself, because it's a member function, fine, and our data, which is a reference to an array of unsigned 8-bit integers. So it's just bytes, just data. And what we're going to do is basically write all that data out to standard out. There's really nothing super exciting about that. That's what we do, and then we return as a result the size of the data that we processed, as we discussed earlier. Okay, so in our init function, which is shown then next, it takes a reference to a curl multi-handle and a URL, and all it does is create an easy handle as an ECE2 type, and creates it with a new vector, and the collector structure is used to wrap it. Then our URL is assigned. We set verbose as false so we don't get a whole bunch of spam printed out to the console about what's going on as curl does its work. And then we add the easy handle to the multi-handle. Sounds good so far. Then in our main function, we will create a vector of our ECE2 handles, and we will create our multi. We will set a couple of items. The configuration items here are not super important, so we won't dig into them, but we set pipelining on it. And then for each URL in our URLs array, we will push it into our initialization function with a reference to the multi so that we add it. And then we're going to perform the multi-perform. Straightforward, and we're just going to do it in a while loop here. It's not necessarily the most efficient because we could be waiting for these things, but we're kind of choosing not to here for the sake of a simple example. And so as long as there are still things in progress, we just keep doing this while loop, and messages might have some info for us here. If they do, we could look at it, but we won't. And then we will wait for a maximum of 30 seconds. We might get woken up periodically here because events might happen. There might be some of the curl handles that we have created that are finished, but we don't care. We're going to wait for them all to be finished before we do anything about them. Because they're all printing to standard out anyway, so we don't really need to manage them, so that's fine. We will just go back to sleep, we will go back to waiting, and that's a plausible option. And then when we're done, we will drain the collection, the ECE's collection. Drain just basically says take each item out of the collection and process it, and what we're going to do is remove the easy handle from the multi-handle, and also note for later what the response code was, should we be interested in that. So let's actually take this for a spin. All right, we have our code as we've just gone through in the slides. There's really nothing new or different here, and all we're going to do is cargo run it. Okay, what did we get? All right, so it turns out that if you just dump random data to standard out, things might not look super pretty. You'll see as we sort of move through the data here, we are getting some of the correct content. We are getting the HTML that we're expecting. We've got some weird stuff shown here. We could also see some interleaving between the different web pages, which can also occur. And we'll also eventually find that we got HTTP 200 from all of the sources, except, of course, one of them which gave us an HTTP code 302, which suggests it was redirected. We were looking in the wrong place. So was this super pretty? Not really, but it did demonstrate that we actually ran using the curl multi-interface, and we do get some multiplexing of the different connections, which is really what we wanted out of this. Before we go on, there's a couple more things to note about curl. One is, could you reuse an easy handle as opposed to destroying, so letting it get dropped and creating a new one? The official doc says yes, but you have to remove it from the multi-handle and re-add it. Otherwise, curl considers it to be the same one and won't update anything on it. It won't restart it. So if you take it out, change it, and put it back, that will be sufficient. You can, of course, always have a situation where there are constantly easy handles in progress, so you never really get to there are no messages left, and that's okay. There's no reason why you are limited in this regard. The developer of curl, the lead developer anyway, Daniel Stenberg, has claimed that you can have multiple thousands of connections on a single multi-handle. About 60K appears to be what's been tested so far, so it really should be sufficient for anyone, for basically any purpose that you need. It scales quite well. If you've learned about curl, you might also know that it can be used to interact with select. Select being the Unix mechanism for managing some asynchronous I/O. Don't. It comes with my anti-recommendation. I think you should not do it, but you can if you want. Curl does some of the grunt work for you if you do that, but I say don't do it. Please no, just use curl as it is. You'll have a much, much better time.